Hello everyone, this is a video example of proof by induction. So remember, we use induction when we want to prove an infinite number of statements. And the statement we want to prove today is that 24 divides the quantity 5 to the 2n minus 1 for every integer n greater than or equal to 1. So we're going to use proof by induction. And we always start by letting people know our intentions. So we'll say we proceed by induction on n. And the first thing we need to do is prove the base case. That's the very first statement that we want to prove. So here, for our base case, we let n equal 1 because n equals 1 is the very first statement we're given in the proof setup, in the claim. Okay, so when n equals 1, we see that 5 to the 2n minus 1 is 5 squared minus 1 equals 24, which is divisible by 24. So the base case holds. Okay, so now we have to prove, we have to do the induction step. So we'll say that we need to show that if for some n greater than or equal to 1, we know that 24 divides 5 to the 2n minus 1, then 24 is also going to have to divide 5 to the 2n plus 1 minus 1. Okay, so remember, this is the induction, showing this is the induction step, and the induction hypothesis is the thing we get to assume. So I'm going to underline the induction hypothesis in red, and the conclusion that we need to show is in blue. Then 24 divides 5 to the 2n plus 1 minus 1. Okay, so let's go ahead and do this. We're going to say, observe that 5 to the 2n plus 1 minus 1 is the same as 5 to the 2n plus 2 minus 1. And here, the trick is going to be to somehow see the thing we know about inside the thing that we have here. Okay, so let's see. I guess 5 to the 2n is something that we know about. So let's see, we can rewrite this as 5 to the 2n times 5 squared minus 1. And let's see if we can just keep doing some algebra. Actually, I think I'm going to erase that and put this down at the bottom. So this is the same as 5 to the 2n times 5 squared minus 1. And let's see what we can do. Well, we know by the induction hypothesis, we know that 24 divides the quantity 5 to the 2n minus 1. So this implies that there exists some integer k such that 24k is equal to 5 to the 2n minus 1. And in particular, if we wanted, we could solve for 5 to the 2n in that equation, and we could get that 5 to the 2n is equal to 24k plus 1. So now let's see if we can use that in the equation that we got, or the expression that we get right here. Okay, so we know that since 5 to the 2n plus 1 minus 1 equals 5 to the 2n times 5 squared minus 1, and now we're going to substitute in for the 5 to the 2n, the 24k plus 1, and then we have 5 squared minus 1. And now what we have is 24k times 5 squared plus 5 squared minus 1. But this 5 squared minus 1 is really a 24. So we have 24k times 5 squared plus 24. And that is equal to 24 times, the 5 squared is 25. So 25k plus 1. So we can say because 25k plus 1 is an integer, what we see from that last line is that 24 divides 5 to the 2 times n plus 1 minus 1. And then we can say that by induction, 24 divides 5 to the 2n minus 1 for every n greater than or equal to 1. And that's the end of the proof. And just to briefly recall the logic, so we've had this sequence of statements, an infinite sequence of statements. 24 divides 5 to the 2n minus 1 for every integer n greater than or equal to 1. We showed that this is true when n equals 1. Then we said if we could show that the statement is true, that if the statement is true for some n greater than or equal to 1, and then we could show that implies the statement is true for the next n, for n plus 1, we'd have shown it for all integers n. Okay, I will stop this video here.